I've been a chemical engineer for about 10 years now. Roughly half of that time, the first half of my career, I spent on a chemical plant, so I got to know the operations side of chemical engineering. After that, I moved to another company where I focused more on what could be considered almost process design and the engineering that happens before a plant is commissioned, as well as the services that happen after that plant has been commissioned. So you can kind of think of them as almost like blue and white collar engineering. If you hear that and you think white collar engineering is better than blue collar engineering, that's not what I mean. I just mean that I certainly sweated a lot more when I worked on the plant, hence the blue collar. Definitely when I was studying, the feeling for me and probably most of my peers too was that we all wanted to go into a design space. This was seen as like the sexiest space to be in for chemical engineering. We thought we're going to be doing simulations and designing distillation columns all day. Now that I've seen both sides of that coin, I thought it would be pretty useful to share those experiences with you and see what the upsides and downsides of both environments are. You get the point. Let's start with working in an operations or manufacturing environment. The first real upside of working on an actual chemical plant is you learn a lot and you learn quickly. I remember the first thing that astounded me when I started working on my first chemical plant was just how many pumps there were in the place. And university didn't prepare me for that. I remember putting pumps into process flow sheets when I needed to increase the pressure of a liquid stream. I didn't realize you need to do that a lot to move fluid around. In hindsight, it's obvious, but if you're sitting doing flow sheets, it isn't something that you're actively thinking about until you actually get out onto the plant. You start to learn things like the fact that mass and energy balances, you're never going to do one ever again where it's going to work. Of course, you do the mass and energy balance for a flow sheet when you're designing a plant, but later on, you'll be lucky if you even have instrumentation on a unit to do mass and energy balances with. And sometimes too much information is also a bad thing because most of these instruments are contradicting each other and you have to figure out, well, which of these values can I trust? So you're always juggling between having too much and too little information, and you need to make sense of all of this. This is a great thing to learn when you're working on a plant. So if you're the kind of person that reports temperatures to 2 decimal figures, working on a real plant will kick that right out of you very quickly. I've worked on furnaces that operate at 1,000 degrees, and you can change that reading of 1,000 degrees by 100 up to 200 degrees simply by moving the location of the temperature sensor that you're using to report that. So 2 decimal points, stop doing that. So that sort of gut feeling for what matters and what doesn't, you won't get that unless you've worked on the plant. So I urge you, if you do work in an operations space, use all the time you have to go out and investigate. That place is a gold mine. Go out and learn everything you can. The next thing about working on a chemical plant that's really great is you are able to witness the effect of the changes you make. So you can have a direct influence on something and see it happen. That's not to say making changes on chemical plants is easy. Understandably, the chemical industry is a conservative industry due to safety aspects of it, right? So we don't want a whole bunch of young upstart engineers making changes all over the place. But once you've developed a bit of experience and you've gained the trust of people around you, it's really satisfying to be able to plan tests, recommend changes, and eventually come to a point where you say, that thing over there, that wouldn't exist if it weren't for me. We're making this much more in production, we're saving this much energy, we are using this much less steam. Those are really, really tangible and satisfying things to be able to say. One of the things you might end up suggesting is a test run where you have a hypothesis for, okay, if we change such and such a parameter or a mode of operation, we think that we can save this or increase that or improve something else. A test run enables you to actually see whether that hypothesis holds any water, because one thing is thinking of it in theory and another thing is, well, what's going to happen in practice? Being on a plant lets you do that. The third big benefit is a combination of those first two things, which is that after you've worked on a chemical plant, this stuff looks really good on your resume. I personally would not have been able to move out of my work on the plant into a company that does technology supply had it not been for that experience. Anyone can say yes, they understand maintenance procedures or standard operating procedures, management of change, risk assessment. It's kind of like saying project management on your CV, right? Anyone can put that, but it's very different saying that you know about it or understand the concepts of it to actually saying, you know what, I've been involved in this all the time. So that really stands you in good stead. And once you have that experience in an operational environment, if you ever choose to move out, moving back should be equally as easy because, well, you've got the experience, you know what it's like to work on a plant, you've got hands-on experience, and now you've got the benefit of maybe having moved out, so moving back is not a problem. Speaking of moving out, that brings me to the first real downside of working in an operations environment, and that's location. Big chemical plants, people don't like to have them in their backyards, right? So power stations, steel mills, mines, they're usually located far away from cities, or else the city that they're in has developed because of that industry. And so this one's quite close to me because this was ultimately the reason that I moved out of my job, was that for 5 years, I only saw my then girlfriend, now she's my wife, only on weekends. So what I would do is commute from the city where I worked, the refinery town. I'd go back to where my girlfriend lived. It was about 170 kilometers away. And I'd travel back and forth. Basically, Friday afternoons, I was with her, spent the weekend, then 4 a.m. in the morning, go back to start my week normally on a Monday. And this became really, really draining, and it's not sustainable. At least it wasn't for my case. Some people are lucky because maybe their partner can move or their families can move, and then it's okay. You can build a really, really good community because all your peers are in exactly the same position. And if it's a small town, there's nothing much else to do other than be sociable. So the communities are very tight-knit, and that's a nice side. But it also means that you likely can't go to the store without bumping into colleagues or someone from work. Downside number 2 is the work can be extremely stressful. You're supporting an operating unit that probably runs 24 hours a day throughout the entire year. They don't really care about your sleep schedule. You need to be there to support the plant in case of emergencies. You need to keep it running. That's what you're there for. The other thing about these places is that hierarchies are really strong and solid in them. And if you think about it, the reason for that is if you're a production manager or a maintenance manager of a plant, you've got a lot of responsibility on you. Not only are you responsible for making sure that that unit is running, it's operable, it's maintained, and it's making a profit, you're also responsible for the safety of all the people that are in that place. So whatever you say goes. What that means, though, is that a lot of stress can be artificially created by those who have the power to make decisions. Often you get a manager that gets very focused, hyper-focused. They have a pet hate, or there's a parameter that they don't like and they need something done about this. And if you're the engineer responsible for sorting it out, it can give you a lot of stress for, well, you don't really have the tools necessarily to solve that problem. And it's only because it's on that manager's radar that it's an issue. You'll see that if you wait long enough, they'll move on to another problem and start bugging someone else about that. And all of that stress just goes away simply at the whim of a person. So yeah, there's genuine stress, there's genuine time pressures, but then there's also a lot of things where you think, why was this even an issue in the first place? So you can find yourself in situations where you're stressed, you're upset, you're really pissed off with someone, you've resigned 16 times in your head and you've searched for other jobs, and then all of a sudden it goes away. And so all of that should teach you that the best thing you can do, easier said than done, is don't take anything personally. People are under a lot of stress. The more you take on board, the more difficult your own life is going to be. And being stoic about it is probably the best approach. Then when things aren't stressful, when everything isn't falling apart, working in operational environments can actually have the opposite problem where it's just so freaking boring. The plant's running stably, everything is operating exactly as it should be, there's nothing to do, you sit around and you think, well, what am I doing here? So you seem to flick that switch a lot between hyper stress to what the heck should I do? And all I can do is urge you that if you're in that environment, get out there, and when things are boring, go and look and learn. I know it's difficult to do, but you really should take advantage of the fact that you're in a really special place. And that brings me to the final part, which I could consider a downside of working in a chemical plant environment, and that things can be repetitive and stagnant if you're not careful, especially depending on which unit you're working on. Chemical facilities consists of multiple units, and some are the shining light of the entire facility. They are the money makers. They get a lot of attention. They get a lot of funding. That's where everyone wants to be. And chances are you're probably not going to be at that place. You will be at a supporting unit or a waste treatment unit or a utility unit where it's less glamorous than that star unit. And you'll often come across problems that have been there for a really long time that no one's been able to solve. There's always that operator that works in a place he's been there for 20, 25 years, and he's seen dozens of engineers just like you walk through the place, and he can say, yeah, that's always been like that. Yeah, they tried that already, that didn't work. And you think, like, I've been tasked with solving this problem and you're telling me it still exists and no one's been able to solve it? So look out for those problems where you think you've just been given the same problem that every new start engineer, say, has been given on this plant. Because you don't want to be given that hot potato that no one else wants, but you also don't want to just be a negative person that says, oh no, not my job, not my problem. You should look at it with fresh eyes. You might just be dealing with a problem that, well, actually no one could be bothered to solve it because you could do it with money. It's just no one's going to pay up. It's a really weird environment in that if you want to make any changes in an operational environment, you need to do them without spending money. Chemical plants hate spending more capital fixing problems that shouldn't exist. I remember looking at a problem where there was a pump giving issues, the fall was flowing away erratically, but there wasn't enough instrumentation on this pump to troubleshoot it properly, to know when was this problem occurring, when wasn't it. So I needed, just as a basic thing, pressure gauges to be installed on this thing in order to adequately troubleshoot it. And everyone agreed that this was a problem, but no one was willing to spend money on it. However, I was being sent on training courses on pump operation and maintenance, and in those courses I'm learning, well, in order to adequately operate and troubleshoot pumps, you need pressure gauges. So a company will be willing to spend money, send me on a training course, but they wouldn't spend the money to implement the things I was learning on that training course. And you think, what the hell is this? But that's the way it is. Spending money is difficult because if every engineer gets his or her way and starts spending money all over the place, well, you're going to run that company into the ground. You're going to have to learn to deal with that balance. So let's look what it's like to work in the white-collar engineering environment, meaning process design houses, technology suppliers, service providers, where you're actually providing services to the people who are eventually going to be operating and owning the plants. The biggest benefit for me in working in a place like this is that I got a much more fundamental understanding of what goes into the design of a process. I was lucky enough to be able to work on a specific plant that used a specific technology and then move into the company that supplied and designed that plant. So I was able to go from knowing how my specific unit operated to going to a place where I could see the design documentation, the simulations, the calculations, and all of a sudden everything started becoming clearer. I understand why that temperature looks the way it does. I understand why this layout looks like this, or these settings are like that, why that alarm limit's here and not somewhere else. So all of that came from being able to look at not only the design of my plant, but other similar plants. And I couldn't have picked that up just by working on the plant that I was working on. So when you work on a plant, you know that, okay, this temperature needs to be this. If you're supplying the process for that technology, you might know that temperature can be in this range. And it just so happens for this unit, it lies here, but it lies in this range because of these considerations. It also gives you an appreciation that there's no black and white, purely correct answer. If you're working in a design type environment, what you'll learn is that things can operate in a range, and you can say to someone, here's the safe operating range. If you go above it in this direction, the risk is X, Y, and Z. And if you go too far in the other direction, the risks are A, B, and C. That doesn't mean that you know exactly when things will fall apart. I kind of like to think of it in terms of like a speed limit. We can set a speed limit for a road, and you might drive a little bit over that speed limit and be totally safe. On the other hand, you might also drive below that speed limit and have an accident. No one can say at 1 kilometer per hour above or below this happens or that happens. We can only say the risks are X, Y, and Z, depending on which direction you move. So when you're dealing with the customers that you supply these plants to, you can get very frustrating questions like, well, this temperature is 180 according to your manual. What happens if I operate at 178? What happens if I operate at 177? These discussions can get a little bit frustrating because you can talk about the risks, but you can't say at this temperature things break. That's not how it works. And ultimately what you end up doing is you're advising someone, a plant owner or an operator, that this is what they can do, this is what they shouldn't do, but ultimately the responsibility is on them for whatever decisions they make, just like the responsibility of driving a car is on the driver, not the person setting the speed limits. And this leads me to the second upside of working in a design environment, which is that you're not only looking at one plant. As I said, you've gained this fundamental understanding because you've worked on multiple projects, which means there's a little bit more variety. You start applying your knowledge to new scenarios, new feeds, new locations, totally new design briefs, but you have a toolbox for solving that problem. So there is more variety in the work, and these projects have more defined timelines, so things are at least changing and you've got a deadline to work toward. So it's not the same as like in a plant where some problems have been there for 20 years and they seem evergreen and you're not going to make an impact. It's quite satisfying to know that there is a deadline, an end date to this. And in dealing with different projects, you're dealing with different people every time. You've got new customers and they come to you with different questions. So you may start hearing the same question being repeated. On the other hand, someone might come along and challenge something and say, well, why does this look the way it does? And you may not have the answer to that, but that reinforces your understanding of a specific technology and ultimately makes you a better engineer. I suppose it's important to note that I was a service engineer, which means that I was supporting customers of existing running units, but a lot of the work did have to deal with new designs, new proposals, and so that role was quite varied. But interacting with new customers was really, really one of the most satisfying things for me. So using your expertise and your knowledge, you can share that with someone who doesn't necessarily doesn't understand your technology or is new to it. It's really satisfying being able to explain something to someone and help them understand it. That brings me to the next pro, which is that working in a process design type of environment, a white collar environment, is a little bit more normal or regular in quotation marks. It is the closest you're going to get in engineering to working the same way as your friends who maybe sold their souls and went into finance. So your working hours will be more regular. You aren't going to get panic phone calls at midnight that something stopped working. You'll be able to have a routine, but you will still have likely the opportunity to travel to site occasionally and go onto the plant for a new build or commissioning. You'll be able to go to meetings and review sessions and HAZOPs, and going on a trip like that feels like more of a treat as opposed to if you're going out onto the plant every day where it feels like a chore. Because ultimately you know that you're going to be coming home and settling into your regular routine, which if you've worked on a plant for a really long time with erratic hours, it's quite comforting. Right, so what are some of the downsides of the environment? Well, I would say the biggest one is it's the opposite to what I said for the plant environment, where I said it's really satisfying to be able to recommend, make changes, and see the effects of those changes. In a design environment, you feel quite powerless. You can only make recommendations, and whether or not your customers follow those recommendations, that's not up to you. Yes, that means you don't need to take responsibility for those decisions necessarily, because like I said, the responsibility lies on the driver of the vehicle. But at the same time, sometimes you want to make a decision and see impact, and that's not in your hands. It also means that you're often forced by your customers to take on responsibilities where they are not willing to take the risks. So you're supposed to be the expert, right? You're supplying a technology or you're designing the process. You're the subject matter expert. So they'll say something like, you recommend that I operate this piece of equipment at 180 degrees. I'm operating at 170 and I'm seeing this problem where I've got corrosion, I've got leakages, I've got a blockage, and my yield is down. And you say, yes, that's because you're not running at the recommended temperature. And so you can get into a conversation where they say, yeah, but we've always run at this lower temperature of 170. And in fact, next week we're running at 160 because there's no budget for this, or someone else has made that decision. Can you assure me that nothing's going to go wrong? Also, we want to skip our next maintenance cycle. So please tell me that everything's fine. And you can only say, well, no. Once again, you're issuing recommendations and you think, I'm not going to take that on board. You're the driver. So that can be quite frustrating, and it happens regardless of whether you're designing a new plant, whether you're in commissioning, or you are servicing a plant that's been running for a little bit. People always challenge why you do things a certain way, and they'll want to change it. And wanting to change it means they want you to take the risk for that change. Final downside I'd mention is that, kind of like on a plant, the work can sometimes feel a bit repetitive and almost like a grind. But where on a plant it's a bit more boring because nothing's happening and everything's stable, here the boring aspect of the work is that you're working in projects, you're working with new projects every time, and there's a lot of documentation to generate for these projects. There's manuals, there's drawings, there's data sheets, there's reviews, and you have to keep spitting this stuff out all the time. And eventually it might feel like you're just this paper crunching machine, and that can be a little bit annoying. So that's my take on those two environments. Given my background, I have to say that I think I am extremely fortunate to have had the experience that I have had up until now. And if you're sitting agonizing, if you're sitting with a choice between these two environments, you're not going to make an incorrect choice. That doesn't mean that you're not going to end up being unhappy in one of those environments. It just means that you will learn something, and that stuff will be useful. I would say don't become stagnant in either of those positions, because it's good to have a holistic, an overall view of chemical engineering, which is what goes into the design of the plant and then what happens for the next 20, 30, 50 years that this thing's running. Ultimately, having background knowledge of both those will make you a better engineer. My final takeaway from you is that nothing that makes me passionate about my work, my industry, and my career ever came from a task that was given to me by a colleague or a manager, right? Everything that I find really interesting, I kind of had to go find myself. So when things are quiet and when things are boring, go and look and question, why are things like this? Who did this? Why did we do things this way? Go out onto the plant, go look at old design information. It's all there, but it requires that you go and scratch underneath the surface to see what's there, because regardless of the environment, there are improvements to be made and they're dying for you to come and make them. It's going to be difficult, but I'll tell you, it's rewarding.